Okay, gang, we're going to find the derivative of this and then evaluate the derivative at this coordinate. Now, I'm going to use a quotient rule on this, but technically you could bring the t up and use the product rule. And again, anytime with trig, the textbook will do some modifications using the trig identities, and I just leave it up to the student to modify as far as they want, as long as like the fraction's completely reduced and they've done all the steps correct. I don't force students to make I don't require, force is too strong a word. I don't require students to use trig identities to modify. All right, so I'm going to use the quotient rule. So the denominator times the derivative of the numerator bottom times top minus top. So numerator times the derivative of the denominator over the denominator squared. Okay, so let me just get my notation correct because I didn't notice I'm fiddling with different variables. This is a t. We're in terms of t and h, so this would be a t, this is an h. Yeah, let me just make sure my variables are consistent with what's in the problem. All right. So this derivative is complete. Now I'm just deciding if I want to do anything to it, and glancing at it, I want to pull out the common factor of a secant. All right, so for me, I like this format. I'm now going to go ahead and evaluate this derivative at this t value of pi. So I'm plugging in pi for all the t values. Now, this is a pi. Pi is a quadrantal angle. So when I'm thinking about evaluating pi, my brain is using the tool of the unit circle. Right? We use this tool when we do quadrantal angles. And if you recall, a quadrantal angle is when you fall on one of the axes. All right? Now, the thing is with secant, to use a unit circle, we have to be in terms of sines and cosines. So it just depends, or if you just know what the secant of pi looks like, then you're welcome to do that. Some people are very good with like the secant and tan graphs. So it just depends. It just depends how your brain works. If you know secant pi straight up and tangent of pi straight up, then go ahead and do it. Okay. So again, secant is 1 over the cosine. So part of this is just figuring out how you like to solve things. So you might be looking at the way I'm solving it and be like, oh, I love that. Or you might be looking at it and be like, I don't like that. I don't want to solve it that way. Okay, so it's sort of like finding your own style and what you like. All right, so secant, the reciprocal identity is 1 over the cosine. Cosine of pi, as you can see, is -1. Sine of pi is 0 over cosine of pi, which is -1, all over pi squared. All right, this looks a little weird just because I've been using the reciprocal and quotient. This is the quotient identity for tan. Now 1 over, it's going to start to look real normal now. 1 over -1 is -1. I'm just going to add an extra step here. You guys probably don't need it, but I'd rather write it to make sure I'm not assuming. 0 over anything is 0, right? So we get that. All right, now we're almost done. Now 0 times anything is 0. So in the numerator you have -1 times -1, which is +1. And pi squared you can just leave as pi squared. Now, this would be the exact answer. You can, of course, I prefer this, 1 over pi squared, but you can, of course, approximate that. Let me just see if I have a pi key. I do. So sometimes the calculators have a pi key, which is really cool. So 1 divided by pi squared. Okay, and then I'm just going to do this just in case your book approximated, but I'm assuming it didn't. I can't see with the glare. 0.101, around there. Okay, but again, this is the better answer versus the approximation. Okay, gang, I hope that helped. Catch you. Bye-bye.